Well, it feels like it's been forever. Finally back to the 1050. I kind of took a week off, a week off from this because I got busy with my real job, my full-time job, and then I was watching the shop for the owner and just really didn't have a lot of time to jump back in on some of these projects. So hopefully this week I can get caught up. So back to the 1050, I received the trim pots. I thought I had the trim pots in stock, but I don't, so we're going to replace all of those. One thing I did notice is the tech that worked on this last did replace some of the transistors, but not all of the transistors. So I do see some 992s in here in different spots, but it has a lot of the original, like what are these, 1439s. These are original, these are replacements. When I look at Audio Karma with but 3 of the 4 trim pots were not replaced, and then there are a whole bunch of older transistors still in here. Things I want to point out before I jump into the part of the video where I'm replacing the components. So some pitfalls to avoid, and I learned this the hard way when I worked on my 1050. So I got a 1050, it was essentially a boat anchor. Soft start was cut out, was missing. A bunch of wires were cut. I mean, it was just a piece of junk, right? I mean, great receiver, but in the shape that I received it, it was a piece of trash. And it was the first big receiver that I had worked on, and I made a ton of mistakes on it, right? Frustrating, not painful to me physically, but painful mistakes. So here's what I want to point out, because I'm not probably going to do this on video. I may just speed through it. But a couple of things that you have to remember when you're removing the outputs in the amp board, right? Number one, you've got screws holding the heatsink into position. Luckily, the screws are there. You want to remove, right, loosen these 2 screws, right? If you break these, I think these are thermistors. I think it's what they're called. And please don't blast me in the face if I got that wrong. But you want to make sure that you unscrew these. If you break these wires, if you break these components, I mean, they're a pain in the butt to find and then replace them with a good component. So you want to make sure you unscrew these and be very careful. So where I made a mistake on my first one is when I removed these plastic clips, I would flex them back and forth, right? Because you would think, oh, I just need to wiggle this off. And what I failed to realize was that flexing back and forth actually caused some of the solder joints to crack and a trace to break. So the procedure I use now is to take a little screwdriver, and this has been off for like a month, right? So I'm not real worried about any shorting anything. But I take a screwdriver and I kind of put it into the gap between the clip and the posts, and then I just kind of wiggle it that way, and then once I get it loose, I'll use like this tool and then pry it open, right? Or pry it off, I should say. So that way I'm not flexing back and forth. And after I put it in, I will double, triple, quadruple check to make sure that I do not break any traces here. There are 2 screws on the top. Screw here, screw here. But essentially what happens is heatsink comes off. These are replaced, if I remember correctly. These are not replaced. These are detached. These are detached. These screws come out. This board slides up a little bit because there are little hooks on the bottom that hold it in place, and then the heatsink with the output should just come right up. And then this board I can actually push through the bottom, and then I'm going to lay some cardboard down and kind of flip it up while I work on removing and replacing the components. I'm also going to check the back of this board really good for any broken traces after I repair it, because there is some flexing back and forth, right? So yeah, it doesn't look like it. Well, no, it looks like a couple of the. Well, we'll see when we flip it over. It looked to me like maybe there were a couple of the wire wraps in the bottom that were soldered back, but maybe not. But I can't really tell from up here. So anyway, that's what you'll see in the next part of the video. I may just shoot this and speed through it, removing this board, so you can kind of see what that procedure looks like. But then we'll get to replacing these components and see where we're at. Again, the shop owner wants us to be completely recapped. I'm going to start with the amp board because I do see some issues that may be causing the popping sound that we're hearing. And then I'll see what he wants to do. If it's resolved by replacing the components, I may, if he wants me to go through and just recap everything, I may go and do it. But generally, I don't like to just recap everything. Well, I don't like to recap everything if it's going to be a difficult job. If it's a simple job, then I'll do it. But something like this is pretty time consuming and can be pretty expensive. So anyway, next thing you'll see is me taking this apart and working on replacing components. Alright, so that's, oh my gosh. It's a big heavy receiver, likes to pull on all this stuff on my bench. So before I jump into replacing components here, let's first take a look at what we've got. So it looks like, well, that's a problem. All right, so that would be the left channel. That's not where we were receiving the popping, but these have been removed and this wire is broken off of there. Looks like this has been removed and looks like it was kind of soldered back on there. This wire here has been removed. Sorry, my big head's in the way. And kind of sort of soldered back on there, not wrapped. So we're going to have to address these, make sure they're on there good. You can see kind of where the components were replaced in the back here. I know you don't want to see my head. So what I'll have to do is I'm going to take a real good look, not right now because I'm going to first work on replacing the components, but I need to take a look at solder joints just to make sure I don't see any bad ones. I may just touch everything up while I'm back here. I mean, it wouldn't take all that much time to do. So what I will be doing, although this is discharged and I don't really think that there's much of a risk. If you look, I've got filter caps right there, kind of exposed. So I like to use some kind of cardboard to just kind of put the amp board here. Gosh, that's not good. This is upside down, so I'm thinking because the popping was coming from the right channel, this is left, this is right, flipped upside down. But anyway, so I'm going to start by replacing the trim pots, take care of these two drivers, and then look at replacing some of these other ones. I want to make sure both sides match. Like I said, the caps were done. So that's what I will be working on now. I am going to pull this one because that's just a hideous repair right there. So all my stuff is warmed up. I'm going to get my parts here and get started replacing some components. So I removed this one. I just want to show you what the other technician had done. Let me make sure I can see here. Because the spacing on the wires was off, the other tech had soldered a little piece of wire onto the middle leg. Again, not incorrect, just very ugly. That's a very ugly way to do that. So anyway, just wanted to point that out as I'm going through here and replacing stuff. Well, one of my trim pots fell out. I do want to test these just to see kind of where these are at. And really, I'm most concerned about what the overall resistance is on these. So going from kind of right to left, I guess. So this one should be, this is supposed to be 470, so it should be 500, so that's 0.5 mega ohms, so that's 500. That one looks all right. I mean, at least general, right, resistance. This one is 432K, right, again, supposed to be 470. This one's supposed to be 2.2, I believe, hopefully, because that's what I bought. Yeah, 2.3K. And this one is 2.2K. So even though these look good, right, and the way you can test these is as you turn it, you should see the resistance kind of flow from 0 all the way to max value on either side, and every point along the way, right? And sometimes there's oxidation or corrosion that builds up and it causes problems with those. So those appear to be okay, but they are also known to go bad. So while we got the board out, why not replace them? We got some 2.2K and these are facing up. I've never used these before. I think these are multi-turn. So what that means is, well, maybe these are single turn. I don't know. Kind of went with what was recommended online. 2.2K. When they are installed, they point up like that. So you get your screwdriver on that little screw right there on top, and you can adjust the whatever you adjust with these, DC offset or bias or whatever. I haven't looked at the schematic to figure out which ones these are exactly. So I'm going to go ahead and install these, and then we're going to go on to those two transistors there and check out the other transistors in the board. Well, my thermal compound application skills are left a little bit to be desired. Need a little bit of help on that one. For some reason, I got it all over. So trim pots replaced, transistors replaced. Now I want to look to see what we've got going on. So we've got 992s, 1439s, 992s, 1439s, 1439s. So what I'm going to do is replace those 1439s and 992s are a modern replacement. So I'm going to have to look at the schematic and see. Actually, let me just look at my list here. Looks like 1439 in those positions, 3503s. It looks like a 2SC 3503. And let me check my stash here. I should have some, and I do. I've got some 3903s. So I'm going to replace those 1439s with 3503s next. Alright, so I found two more that I did off camera. So now I'm going to do the 858s with 1381s. So I'll film that next. And then I think just have a couple of those and then a couple of other values that we'll have to replace. So I'm going to jump on that now. Alright, so all of the transistors have now been replaced with values I found off of a parts list on Audio Karma. Looking at the board, couple of solder joints here or there I'm going to touch up, but overall the board looks pretty good. You know, you're looking for hairline cracks, kind of circles, you know. I don't see any. Now that I've removed and replaced the components that tend to get hot, I don't know that there are any other ones to touch up. Now notice how I was flexing the board back and forth. That's how these wires will break off. Right, so, and if you're not familiar with how these are wrapped, so these posts, some of these posts are square. They have sharp edges. When you wrap the wire, it actually puts little cuts in the wire. So when you go to unwrap them or remove them or flex them back and forth like this, where those cuts are, sometimes the wire will break. So it looks like it's just that one, but, and what I need to be careful about is when I do this, see how it wasn't even, it just, I'm not sure what happened there. It looks to me like it probably broke off with the last repair. I can't find my pliers. Oh, there they are. So, but that was pretty ugly. What I'm going to do is see if I can just pull a little bit of wire out of here. Just enough to tack those into, kind of wrap it a little bit and tack it into place. Maybe make it a little bit cleaner than it was, but not much wire to, there's not a lot to use here. In fact, the black one I may just leave the way it was. May just put it back on there and put some fresh solder on it. My high-tech stripping tool. It's not a lot of wire. But let's see if we can make that work. Alright. And we have to do this side first. Probably should have left that side alone. And then get that one on there like so. And solder them into position like that. I know this is not very riveting. Alright, in fact, I'm going to just do this real quick and make sure that holds. Okay. Boy, that's as ugly as it was before. But I definitely don't want that to come loose again. Or break. So, big solder blob. Solder blob? Tongue twister. Alright, so I think I'm pretty comfortable with the work that I've done on that board. And I believe we can put this back together and give it a whirl. Alright, well, you don't need to watch me fumble with these wires and putting this back together. So next time you see it, I'll have it flipped over, turn it on, and we'll see what happens. Alright, been 5 minutes. We're going to adjust VR1 and VR2. Those are the two innermost pots. We're going to set those to, we're going to turn them until we see 0 on the DVM. There we go. Okay. Pretty touchy. It just wants to hang out there, huh? Kind of weird. Just wants to kind of stay there around 10. I haven't turned it all the way down yet, though, so. These pots are very, very, that little adjustment screw is very tiny. We'll see where that lands. It should be... Yep. Should be getting close. It's kind of boring, huh? Well, this is kind of boring. So, got down to close. So I'll keep tweaking this on both channels, and then we'll come back and we will do the bias setting. Looks like I may have got this one. That's probably gonna be as dialed in as it needs to be. 1.4 millivolts. I may tweak it just a little bit more, but it seems to be kind of bouncing around. So anyway, we'll jump back in when I'm doing the bias adjustment. All right, so I got both right and left channel adjusted to about 0. I mean, it fluctuates. Both of them are fluctuating from like a half to negative a half, so I think that's pretty good. So it's kind of evening out at 0. So for the bias adjustment, we're going to go negative to pin 6, negative to pin 2, positive to pin 6. I know this is really boring to see when I just have it flipped up on its side. But we'll be turning the outermost trimmers that we installed. So we're going to go negative to 2, positive to 6, and we're going to get 50 millivolts. Alright, so we should see that moving once I start turning it the right direction. So there's 50 millivolts on the left channel, and for the right channel we're going to go negative 19, positive 15. So positive 15, negative 19. And we will adjust this down to 50 millivolts. Close enough for me. Right, so 50 millivolts DC offset bias has been adjusted on the receiver. So I'm going to power it off, put the bottom back on, and fire it up and see if we're still getting any popping or anything weird going on. Bottom's been attached. I'm going to power this on the dim bulb tester initially, just to make sure something didn't go haywire on it. Soft start. Protection. Let's see. Okay. Getting sent. Whoops. Didn't mean to do that. Shut it off. Oh, okay. Alright, so what I'm going to do now, put this on power, and I'm just going to let it run for a little bit, see if I hear any popping. I'll have to review the video, but I think the popping was almost immediate. So I'm hoping this remedied that situation. I do want to check out one thing though. So the AM antenna is cut on this. So I wonder, yeah, I get, oh, it does. I do get some AM stations. Very faint AM. So, I know on Yamaha that's like a circuit and it doesn't, AM won't even work at all in a couple of Yamahas I've worked on with that problem. So, alright, so I'm going to let this run for a little bit and see what happens, and I'm going to have to get with the owner to see exactly what he wants to do as far as additional work on this. He may be happy with this repair because if you look at how much this cost, right, in terms of expense for getting rid of the popping noise, you know, not much time and not much in terms of parts. So anyway, we'll come back to this and let this run for a little bit and we'll see what happens. Alright, so I have identified a couple of additional issues on this. So while testing FM tape monitor with the tone control on, I'm getting more volume in the left channel than the right, so probably an issue in the tone control board. Maybe a cap is freaking out or a transistor is bad. So I have to look at the tone control board, recap that. And auxiliary, I'm only getting the left channel on auxiliary. So I need to sort out what's going on with auxiliary in the left channel. So I'm wondering if maybe a wire popped loose as I was moving some stuff around. So, and I also did notice a little bit of crackle when I turned the receiver on with the tone control on. But I haven't tested to see if it does that with the tone control off. So tone control is off right now. Should get a pop here in a second. And nothing. And I'm just curious as to if I get... Yeah, I don't hear anything there either. So a couple more issues to sort out here. No right channel on auxiliary, and then a channel imbalance when the tone control is set to on. So it looks like we have some more work to do. And I'm going to save that for part 3, so I'm going to wrap up part 2 right now. I may not be working on this right away because I've got several other projects that I need to look at. So anyway, stay tuned for part 3, and I'll catch you in the next video.